Hello, this is the Section 5.1 lesson. In Chapter 5, we introduced the idea of hypothesis testing. And in Chapters 5, 6, and 7, we're going to introduce many specific types of hypothesis tests. But they're all done in the same basic way. In Section 5.1, we're going to introduce some of the basic terminology and methodology used for doing hypothesis testing. So first, we need to define what is hypothesis testing. Well, hypothesis testing is a formal approach for determining if data from a sample support a claim about a population. So we're going to start off by making a claim about a large population, and then we're going to go out and collect some data from a sample, and we're going to use hypothesis testing to determine if that data support the claim about the population or not. And there's 5 basic steps to doing hypothesis testing. The first step is to state what we call the null and alternative hypotheses. The second step is to calculate a test statistic. And then the third step is to find a critical value, or alternatively calculate something that we call a p-value. And then we state a technical conclusion, and then we wrap it all up and talk about state the final conclusion. Now, different hypothesis tests have different ways of calculating the test statistic, and in subsequent sections we're going to talk about specifics of how to calculate the test statistic. But in this section we're going to focus more on steps 1, 3, 4, and 5 and how they're done, and a little bit about what they mean. So to illustrate the overall process of doing hypothesis testing, let's look at this example of this claim. More than half of the students at a particular university are from out of state. So what we've done here is made a claim about a large population. Our population here is all the students at this university. And the claim is that more than half of them are from out of state. Well, to determine with 100% certainty if this claim is true or false, I would have to go out and interview every single student on this university, take the number that are from out of state, divide it by the total number of students, and if that number is less than or greater than 1/2, then my claim is true. If that number is less than half, then my claim is false. Well, that's impossible to do. I'm not going to be able to go out and interview every single student across this campus. So instead it makes sense to go out and collect some sample data. So suppose we went out and interviewed 95 students, and 59 of them are from out of state. And so we might calculate a sample proportion here. P hat comes out to be 0.621. So about 62% of the students in this sample were from out of state. Now, we might be tempted to say that this data prove my claim, but we got to remember that this is a sample proportion, not a population proportion. This sample proportion is an estimate of the population proportion that I'm making a claim about. So this data here do not prove my claim, nor do they disprove my claim. Now, this number is, of course, a sample proportion, but in the context of a hypothesis test, it's also called a sample statistic. Now, this sample statistic appear to support the claim, but we might ask the question, well, just how strong is that support? Is it really strong support, or is it just kind of some very weak support? Well, informally, hypothesis testing allows us to measure the strength of this support. Okay. So, step 1 in the process is to state the null and alternative hypotheses. Well, before we state these hypotheses, or before we even talk about what they mean, we first need to define the parameter. Okay. So when we define the parameter, we define what it is we're making a claim about. In this case, we're making a claim about a proportion, so our parameter is P. What is P? The proportion of all students at this university who are from out of state. And we stress the word all here because we're making a claim about all these students at this university, not just the 95 students in my sample. Now, the hypotheses are statements about the equality or inequality of the parameter. And we're going to have 2 hypotheses, the null and alternative hypotheses. Okay? So examples of statements that I'm talking about here include the following. The parameter equals some number. So for instance, p equals 0.5. Another example is that our parameter is greater than some number. Another example is that our parameter is less than or equal to some number. A fourth example is that the parameter is not equal to some number. And so now our null hypothesis is going to be a statement really of a form like this. We could think of the null hypothesis as a statement of the status quo. It's a statement that we might expect to be true if we didn't have any data to suggest otherwise. So in this case, we've got kind of two types of students. They're either from state, they're in state, or they're from out of state. And so without any evidence, we might be tempted to think, well, half of them are from in-state and half of them from out of state. And so our null hypothesis is going to be the statement that my population proportion equals 1/2. The alternative hypothesis is a statement about the value of the parameter suggested by the data. Now in our data, we had a sample proportion of greater than 1/2. And so that suggests that our population proportion is also greater than 1/2. And so alternative hypothesis is going to be the statement that p is greater than 1/2. So there's our two hypotheses. So every hypothesis test is going to have a null hypothesis, which is denoted h sub 0, and then alternative denoted h sub 1. The second step is to calculate the test statistic. Now in the test statistic, we're going to take numbers from our data, we're going to take numbers from our hypotheses and put them together to calculate this test statistic. Now different types of hypothesis tests have different ways of calculating the test statistic. We're not going to get into all of them right now. In subsequent sections, we're going to discuss more details about these, how to calculate the test statistic. But for a claim about a single population proportion, like what we have here in this example, our test statistic is calculated according to this formula right here. So in this formula, we need p hat, which is our sample proportion, n is our sample size, and then p naught is the number that's used in the null hypothesis. So we're going to put things into this formula, crunch the numbers, and the number that we get out we're going to call z. And we call this number z because the number that we calculate over here is going to be an observed value of a random variable with a standard normal distribution. Now in section 5.2, we're going to talk more about where this formula comes from and what all it means. So for right now, we'll just take this for granted. And so in this particular example, we have these numbers here. P hat is 0.621. Again, that was our sample proportion that came from the data. N was our sample size of 95. P naught is the number used in the null hypothesis, which is 0.5 in this case. So I plug the numbers into our formula, do that arithmetic, and we get our test statistic of 2.36. Okay. The third step is to find the so-called critical value. Now, different hypothesis tests are going to have different types of critical values. These critical values are just as we define them in Chapter 3 and Chapter 4. A critical value could be a critical z value, it could be a critical t value, it could be a critical chi-squared value. Just depends on the type of hypothesis test. Now, before we find the critical value, we first need to select a number alpha between 0 and 1. And this number alpha is similar to what we saw back in Chapter 3. Alpha is called the significance level, and then the number 100 times 1 minus alpha % is called the confidence level. Now these are the same terminology and same notation that we used in Chapter 3 when we talked, or Chapter 4 when we talked about confidence intervals. These numbers alpha and the confidence level have slightly different meanings here in hypothesis testing than they did in confidence levels, or in confidence intervals. But informally, we can think of the confidence level as a measure of how confident we want to be in our final conclusion. We're never going to be 100% confident, and so we need to have some measure of just how confident we are. So now once we have selected our significance level alpha, for a claim about a single population proportion, here's how we find our critical value. So first we look at the form of our alternative hypothesis. And our alternative hypothesis is always going to be one of these three forms. And if we have the form p is greater than a number or p is less than a number, then our critical value is a z-score, and specifically it's z sub alpha divided by 2. If our alternative hypothesis is of this form, p not equal to p naught, then our critical value is z sub alpha divided by 2. Now for each one of these forms of the alternative hypothesis, we also have a critical region, which is defined by our critical value. And so here we see how to find those critical regions in a test such as, or in a form such as this first two. We see that we have just a critical region is a single interval. In this last form, the critical region is a union of two intervals like this. And so in this claim, let's choose to work at a 95% confidence level. A 95% confidence level is the default confidence level, and so that means alpha is 0.05. Now our alternative hypothesis was p was greater than 0.5, so we have this form. So our critical value is z sub alpha. So z sub 0.05 is 1.645. And then our critical region is right here, the interval from 1.645 up to infinity.